What up, athletes? Whoop, whoop. All right, let's get into it. This is 10.4. Our learning target today is I will apply the distance formula to find the lengths of line segments. It's all about the distance formula today. Go ahead and take a moment, do your warm-up. Pause it, because you know I'm going to get going in just a moment. All right, let's do this. Little two-step problems is one step. Last time, it's 2 steps now. We're going to add 60. First step's pretty much always going to be add or subtract. Second step's going to be multiply or divide. So that goes 2x equals 90. Divide by 2. We know x equals 45. All right. I'm going to add 4x to both sides. And we can walk and chew gum at the same time, right? So I'm also going to subtract 180 from both sides. And that's gone. I get 9x equals, that's 180. That's gone. Divide both sides by 9. And we get that x equals 20. All right. That is an unnecessary set of parentheses. So, because it's just plus, right? So I'm going to add 3x and 4x. And I'm also going to subtract 6 at the same time. Boom. So combine like terms. I'm going to subtract at the same time. I get 4x. That's gone. Equals 84. Boom. Look at that. And when I divide both sides by 4, I end up with x equals, that goes in there 21 times. 21. All right. Again, because of the plus, those are unnecessary parentheses. I'm just going to combine x's. And I'm going to combine the numbers. And I'm going to get 3x plus 2x is 5x. 1 minus 6 is minus 5 equals 180. So let's add 5 to both sides. We get 185. So 5x equals 185. Divide both sides by 5. And we get that x equals what? Goes into 18 3 times, 35 7 times. So 17. That sounds pretty good. No, 37. What am I thinking? Goes in there 3 times, not 1 time. 37. Oh. Okay, let's go ahead and go to our, move things around here. Let's go to our vocab. Distance. The length of the line segment between 2 points. Easy on a number line, gets a little more challenging on a coordinate grid, but we'll talk about that. Pause this, write it down. We're moving on. We're going to talk about distance on a number line. So you'll see right here, I'm going to have you fill this in. You see the picture on your notes right there. Distance formula on number line. If P, here's what I want you to write down right underneath that number line. If P has coordinate x1 and Q has coordinate x2, then the distance PQ, right, that's the measure of the distance, is the absolute value of x2 minus x1 or x1 minus x2. In other words, subtract the points, take the absolute value. Why do we take the absolute value? Because distance is positive. You never say, I read -5 miles, right? We talked about that a while ago. So we just got to keep it positive. So if it comes out as a negative because you subtracted in a different order, you got to make sure you have absolute value signs on the outside to force it to be positive, because distance is always positive. And we're going to do some examples with that. So again, pause this, write it down. I'm going to go back to our notes. And let's take a look at some examples. So it says find CF. And what do we see? We see that C equals -1 and F equals 5. And I'm going to do this 2 different ways to show you why the absolute values matter. Okay? So we're going to do the absolute value. We're just subtracting the x values. -1 minus 5, which equals the absolute value of -6, which equals 6. Look at that. It's a distance of 6 in between. Let's see. 1, 2, 3, 4, 5, 6. Perfect. Or we could have done it the other way. 5 minus negative 1. Well, this is going to become positive anyway, which is absolute value of 6. What's the absolute value of a positive number? Still positive. It stays positive. Same answer. There you go. All right, find AE. Why don't you do that? Write down what A equals, what E equals. Go ahead and do the same for DB. Pause it, and then I'm just going to work it out. So are you ready? I'm assuming you pause it. Here we go. A equals negative 4. B, or excuse me, E, not B, equals 3. So we're going to have the absolute value of negative 4 minus 3, which is the absolute value of negative 7, which equals 7. Boom. Or I could have done the absolute value of 3 minus negative 4, which that becomes a plus. Absolute value of 7 is still 7. And dB, let's look. D is 2. B is negative 3. Let's see, the absolute value of 2 minus negative 3, those become a plus. And I get the absolute value of 5, which equals 5. Boom. Distance of 5. And we can do it the other way, which is negative 3 minus 2. Absolute value of negative 5 is still 5. Boosh. Been a while since we've seen absolute value signs, but we've done them before. They're not bad. So really on a number line, it's quite simple. And most of the time, if they're close together, you can just count them if you want to. There's no reason you can't do that. But if they're super far apart, you're not going to want to count them. So there's that. Okay. Let's go on, and we're going to look at what happens when we're on the coordinate plane. All right, take a minute. You'll see this in your notes. Write down, if P has the coordinates x1, y1, and Q has the coordinates x2, y2, then PQ equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And here you'll notice we don't have absolute value signs in the formula. It's because when you square something, it becomes positive. Why? A positive times a positive is positive, and a negative times a negative is positive. So don't get stressed out by this formula. We're going to go through it, a couple examples. You're going to do great at it. Pause this, write down what you need to, and we're going to roll, ready, set, go. Okay. So, let me zoom in here. So again, this would be my x1, y1, right? And this is my x2, y2. I don't actually care because it doesn't matter which order you do this in. It really doesn't, as long as x's are together and y's are together, okay? So what am I going to do here? I'm going to say, all right, the distance between the points CD. So CD is equal to the square root of negative 4, parenthesis, negative 4 minus 5. I'm just subtracting my x values and I'm going to square them. That's all I'm doing. Notice I just did negative 4 minus 5. Those are my x values. And then plus, I'm going to add to that, parenthesis. Now I'm going to subtract my y values. So that's negative 6 minus negative 1. Make that little radical longer. It's called a radical, by the way. It has a little deal there. It's for taking the square root. And I'm going to square it. Okay? So what does this equal? Well, this equals the square root of negative 4 minus 5 is negative 9. So that's going to be negative 9 squared. Plus, now, minus the negative is a plus, so negative 6 plus 1 is negative 5, so that's going to be negative 5 squared. And which is equal to the square root of negative 9 squared is positive 81. Remember, it's always going to end up positive. And negative 5 squared is positive 25, so plus 25. And when I add those together, I get that this equals the square root of 106. Now, this is not a perfect square. It's not, so we're just going to leave it like this. Unless it tells you to round your answer, leave it if it's not a perfect square. If it's a perfect square, like the square root of 9 is 3, go ahead and feel free to do that, okay? I'll make this a little bit visible, otherwise I can't see what I'm... Okay. So taking this, I want you to take a minute, try to pause it, and see if you can't set this one up. Just plug it right in. Remember, x1 minus x2 squared plus y1 minus y2 squared, or y2 minus y1. It doesn't matter the order. It really doesn't. It'll come out the same. All right, let's do it. So I'm going to have, all right, mn equals, so the measure of mn, that distance, is going to be the square root of, let's see the difference in our x values. So that's going to be 2 minus negative 3, right? 2 minus negative 3, our x values, squared, plus the difference in our y values, which is going to be 4 minus negative 2. 4 minus negative 2 squared. That's going to equal, let's see, that becomes a plus. I'm going to end up the square root of 5 squared plus, that's going to end up being 6, because it's a plus, 6 squared. So this equals the square root. 5 squared is 5 times 5, which is 25, plus 6 times 6, which is 36. Or this equals the square root of 61. Again, not a perfect square. We're just going to leave it. And I'm going to give you a brief lesson. Do you want to know why this works? Because I can make this into a right triangle. And does anybody remember the Pythagorean theorem, which says a squared plus b squared equals c squared? Well, notice for legs A, B, and C, these are simply the legs. So if I want to solve for C, right, which is what we're solving for, how do I solve? If I have c squared equals a squared plus b squared, I'm just going to take the square root of both sides. So I get c by itself, and I have c equals the square root of a squared plus b squared. Well, that a squared plus b squared, first of all, it's under a radical. This is under a radical down here, right? And what is that a squared? That's just the difference in our x values, right, which go first. What's the y squared? Well, that's just the distance, the difference in our y values. And what do? We add them together, and we take the square root. So that's where this formula comes from. I'm not going too deep on it because we'll talk more about it later. But let's go ahead and do one more problem on back. Let's take a look at it, and then you're going to have practicing your homework. And this is a practice makes perfect kind of situation. So Maddie and Julia are hiking at their local state park. Both girls start their hikes at the main shelter but go on different trails. After 3 hours, Maddie is 5 miles north and 3 miles east of the shelter. Julia is 7 miles east and 2 miles north of the shelter. Okay? How far apart are the two girls? So first of all, let's find out. We know that Maddie is 5 miles north and 3 miles east. So let's do that. North is up, so if here's the shelter, she's going to go up 5, right? And then she's going to go over 3 to the east. So she went north 5, east 3. Now let's look at these as an xy coordinate. My left and right is my x, my up and down is my y. So wouldn't this just be the point 3, 5? Okay? And now let's talk about Julia. It says Julia is 7 miles east and 2 miles north of the shelter. So she started out going east. So she went east 7 miles. And then it says she went north how many? 2 miles north? Up 2 miles north. Well, again, the left, right is our x, the up, down is our y, so that would be the point 7, 2, right here. And we want to find what is this distance between them. Okay, well, let's do that. Again, for the point, or points 3, 5, and 7, 2, I know that the distance between, and I should have labeled this, let's see, Maddie was first, right? Maddie, yeah, this is Maddie. And this is Julia, is that her name? Julia? J. So, the distance between M and J, so from M to J, or MJ, is equal to the square root of the difference or subtraction of our x values, right? So 3 minus 7 squared, plus the difference in our y values, 5 minus 2 squared. Awesome. So that's going to equal the square root of negative 4 squared plus 3 squared. Again, let's square those. We get the square root. Let's see, square that. I get 16 plus 3 squared is 3 times 3, which is 9. Watch this. That's going to equal the square root of 25. And it turns out, guess what? That is a perfect square. What two numbers can I multiply together to get 25? That equals 5. So here's what we can say. And we're talking about miles. So we can say Maddie and Julia are 5 miles apart. Well, look at that. What? What? All right, with that said, peace out.